So these are called rate in and rate out problems. And an analogy I like to use in explaining these is, suppose you have a bathtub and you turn the water on, the water starts filling it up. Let's say that water is coming out of that bathtub at, I don't know, does maybe like 2 gallons per minute sound reasonable? Okay. Now let's say you open the drain though, but leave the tub running, right? And let's say it drains at about 1 gallon per minute, right? What's happening in your bathtub, first of all? Is it filling up or is it draining out? It is. It's doing both, but the net rate is filling up, right? Because the water's coming in faster than it's leaving. So you have water coming in, you have water coming out, but the rate, what's the rate at which it's filling up now? The rate at which it's coming in is 2. The rate at which it's leaving is 1. What's the rate at which it's actually filling up? 1, because you subtract them, right? All right, so that's an example of a rate in, rate out question. So if I represents the rate at which something's coming in and O represents the rate at which it's going out, then the total rate of change is the rate in minus the rate out. You just subtract the rates, okay? Now, combining with what we learned yesterday, if you integrate a rate, you get a net change, right? So now if I want to say how much water is going to be in the bathtub after 10 minutes, I would integrate my difference between rate in and rate out from 0 to 10, and that would tell me the total amount of water. So the net change would be if you take your IT minus OT and integrate it from start to finish time. And I've rewritten this in 2 different ways. One is like this, right? That's the original, just integrating it. But I said this equals R, right, up here. So I can just replace it with R. It means the same thing. And then if I integrate little r, that's big R, right? So this is the final amount of water in the tub. This is the starting amount of water in the tub. And when we subtract them, that's how much the water level has changed over that time period, right? So that's net change. But it's just, instead of integrating one rate, we're integrating 2 opposing rates. And of course, like usual, I mean, some questions I'll ask you, what's the net change? How much water was added into the tub after this time period? That would be just the integral, right? But sometimes I'll say, okay, but suppose there was already 10 gallons in the tub to begin with. Now how much is in there? So at that point, they're asking for a final amount, in which case it's pretty convenient to rewrite it like this, where you take the RA and just add it to the other side. So what this means is you have your final amount is equal to your starting amount plus the net change, right? This makes sense. So let's do an example problem here. Sure. Yeah, it's printed. That's okay. Yeah, there was a lot to write there. This is printed as well. And you guys have all the lovely typos. There's like 1 million in here. I don't know why they're here. All right. The rate at which rainwater flows into a drain pipe is modeled by the function R, which is in cubic feet per hour. T is measured in hours. The pipe is partially blocked, allowing for water to drain out the other end at a rate modeled by D of T, which is also in cubic feet per hour. If there are 30 cubic feet of water in the pipe at T equals 0, find how much water is in the pipe after 5 hours. So let's look at what we've been given here. First of all, do you guys see why it's a rate in, rate out? Because they've given us a rate at which the water is coming in. They're giving us a rate at which the water is coming out. And there's that. Now, they've also given me a starting amount of water, and they're asking for how much water will be in there after 5 hours. So they're asking for a final amount. So they're not asking for a net change. So I don't want to just integrate it and say this is how much water changed, right? They want to know what the final amount is. And like I showed you in the last slide, when they're asking for a final amount, it's kind of convenient just to do this one down here. So we're going to have our final amount is equal to our starting amount plus the integral of the rate in minus the rate out on our time interval from A to X. Okay, so let's go ahead and see if we can identify all these things. They didn't give us an output variable, like what the total amount of water is going to be present. So we can just make one up. Let's say it's F. So that's F. Now I want to find how much water is in there after how long? 5 hours. And then what goes here? The starting amount, which was 30. So there's already 30 cubic feet of water in the pipes at this point, right? Now that's how much we start with, but after 5 hours, there's going to be a net change. So what's my time interval here? 0 to 5. And this is not a simple rate. It's not like it's just water's coming in. We have water coming in and going out. So this is a rate in, rate out. We need to put both. We have R of T, which is the rate in, minus D of T, which is the rate out. And there's our formula. Now, this whole chapter, guys, we're pretty much going to be using calculators for everything. So just kind of expect to always grab a calculator on your way into the class until this unit's over. All right, so let's go ahead and do this. Now, in this chapter, you're going to find that we are putting multiple functions inside of our integrals, and when you do that, it's parentheses city. And all it takes is screwing up and forgetting to put one parenthesis in or putting one too many parentheses in, and it gets really confusing. So what I'm going to do is I'm going to show you guys a way where we can, instead of typing these functions all the way out and potentially making an error and typing it in the calculator, because it's really frustrating. You spend all this time typing and then you push enter, it says error, and then you have to try to find it. It's really irritating. So what I'm going to do is I'm going to show you guys how we can type the function one time all by itself and store it under a specific letter. And then when we do our actual integrals in the calculator, we can just put that letter in there. Okay? So let's go ahead and evaluate this integral here. But before I do, actually, what's the units going to be on this? Like, what's my answer going to be? Cubic feet, right? So whatever we get, I'm going to put it there. We're going to say that's okay, cubic feet. Say what? Oh yeah, you could do that. That'd be fine. Feet cubed. So this is cubic feet, right? These are cubic feet per hour, right? But when you integrate, the hour goes away. So we just have cubic feet plus cubic feet is cubic feet. Okay, so let's do the calculation now. Okay. So go ahead and turn on your calculators and clear them if they're not already cleared. So what I'm going to do is I'm going to store both of these functions, the R function here and the D function. I'm going to store those in my calculator. So let's all go press Y1 here, or Y equals. Clear out any functions that are in there already. And my pre-calc kids were using these calculators earlier, so you might want to push mode really quick and make sure we're in radians. If you're not, you might want to fix that. All right, anyway, back to the Y equals. So I'm going to type 20 sine t squared over 35. No, we're going to do x. The calculator likes x. So there's my first function. Let's type in the next one. Negative 0.04 x to the power of 3. Now, when you do this, it's important that you remember which one was y1 and which one was y2. So we're going to say that R is y1 and D is y2. You guys see how they're y1 and y2?
Yeah.
Okay. So now they're stored in our calculator. We could graph it if we wanted to. We're not going to. We're just going to go to the home screen here. So second, I'm going to go to the home screen. All right. Now what I'm going to do is I'm going to type in everything over here. So I'm going to type all this in exactly as you see here. We're going to do 30 plus, now I need an integral, so that's math, 9. And you guys have a prettier looking display than I do. Does anybody have one that looks like mine with the FN? Okay, so follow what I do here. The first thing we're going to do is we're going to put in our functions. Now it's r minus d. Now my calculator thinks r is what? y1. So let me show you guys how to get y1. Are you ready? All right, so you're going to go to variables, right here, VARS, right here, and then you're going to go over to yvars, push 1, and there's all the y's. So if you just push 1, that's y1. I'll do it again, watch. So I'm going to push minus for y2, so I'm going to go to vars, and then scroll over to yvars, push 1 for functions, and then pick whichever one you want. Now I'm going to pick 2 because I already did y1. So what that is that's function 1 minus function 2. And for us that's r minus d. Yeah?
If I did parentheses and y1 parentheses,
Wouldn't be wrong. That would be fine. That would be fine. Now, the rest of you guys can type it in exactly as you're used to doing because it looks nice, but you and I have to mess around a little bit. So we push comma and then x. And that tells our calculator we're integrating with respect to x. And then we push comma again, and then we put our limits from 0 to 5. So 0, comma, 5, parentheses, equals. And there's our answer. It's 30.53. So it's much easier to do that yvars thing than it is to try to type those into the integral. Because you have to use parentheses and all these things and separate everything and type it in just right. This kind of keeps it nice and clean and simple. With what, dear? There's one for you guys. Kirsten. Francisco, what did you get after calculating it? Yeah, you're good. And we'll just round it up because we're talking about what here? People. So we're looking at about 28 people. So they started with 28, and after an hour they had 28. Now, that probably means the same number of people that came in is the same number that went out in that hour, right? So that's kind of interesting. All right. I doubt it, because then the rate in, rate out would be zeros, right? But they're functions, so they're changing over that time period. All right. Let's. Now that's the end of the lesson that I wanted to get to yesterday. So
Let's go on to the next one.
Let's go on to the next one.
Yeah.
Hey. Hey.
I'm so tired.
You say I'm weird.
I'll see you tomorrow. 8 a.m. I'll be at your house, son. With a car and handcuffs. I'll be like, I'm getting in. We doing some house
I'm
cleaning.
coming for 8 o'clock.
Well, then I'll be there.
I'm probably
Where are you going?
sometimes I can't.
What time did the track vegetables start?
Right after the track minimum. I don't know how to temper it.
I did, but I was still trying to get a rise for mine. Sorry. Hey, Jackie gave me some feedback right now. All right. So let's do some more here. Did everybody get one of these? You didn't? Jacob?
Oh, my bad.
Okay, so let's see here. So I'm going to read this. At 7 a.m., there's 500 bees in a hive. From 7 a.m., which we're calling T equals 0, to 5 p.m., which would be T equals 10, right? That would be 10 full hours. The bees leave the hive at a rate of L, and that's in bees per hour, where T is measured in hours after 7 a.m. The rate in bees per hour that enter the hive is given by the other function that you see there, E. So this is going to, most of what we're going to do today is very repetitive from what we just accomplished. So we're not really furthering our learning here too deeply. That's our first set, A through D. The next set of this, E through, I don't know, I or something like that. Those are some different types of questions. We won't be getting to them today. Those are the time. But let's see. How many bees enter the hive from 7 a.m. to noon? So how do you think we're going to solve that? Okay, so we know that's 5 hours. We're going from 0 to 5. That's a good one. That's useful information. Now it's asking for how many bees, right? So it's not a rate question. They're not asking what the rate is. They're asking how many bees. But they gave us a rate. So how do you turn a rate into a change, an accumulation? Integral. The calculator? Okay. Okay. Integral. That's right. Now, it's the integral from 0 to 5, right? Because we're talking about the first 5 hours. Now, the integral of what, though?
Yeah.
What is, now, LT is what? Is that out? Now, the question is asking how many bees have entered the, have entered the hive in that time period. Just E, right? They don't care about leaving. Now, that doesn't mean that a bee wouldn't have went in and came out. Maybe even the same bee went back again, but that would actually count for 2 entries, right? So they don't care about leaving. They just want to see how many entries happen. So we're going to be integrating just the E function. Okay? That's it. How many bees leave the hive from 7 to noon? What would I do there? Okay. Part C. How many bees are in the beehive?
That would be A minus L.
Good. So that's where we got to combine them, right? So it's close, but we're still not quite there. But it will be the number of bees entered minus the number of bees that left. What is this? You got it. Good job. So this tells me, okay, bees are entering this quickly and leaving this quickly. If I integrate it, it tells me how many bees are present after 5 hours, but that's how many have changed, like the net change of bees. But we need to know the starting amount also, right? So we start with how many bees? So we had 500 bees, and then integrating E minus L from 0 to 5 tells you how many bees were added or lost in that time period altogether, and that would tell you the final amount. And this is actually the same question as the last one down here. Part D asks us to write a function, which is B, right? Write a B. Let me scroll down so people can see. Can I erase this, you guys? Okay. So part D says write an expression B of T that would represent the number of bees in the hive T hours after 7 a.m. All right, so that would be B of T is equal to 500 plus the integral from 0 to t of e minus L of t dt. So it's really the same thing as the question before that. It's just that the question before it gave us a specific time from 0 to 5. This one is just a function which means from 0 to whatever time t. Okay? That's it. Nothing new really. I intended to get to new stuff, but time is not our friend. So let you guys do, and I also kind of cheat a little bit. I wasn't doing the calculator work, but I feel like you guys know how to do that already. You guys mind if I just skip that? Oh, are you? Okay. Do you guys want me to do it? It's pretty, it's not too bad. I can do it if you like. Let's do it. Well, you guys are going to do your own set. You just want to do it there?
Yeah.
All right, because I think you guys got the calculator stuff down pretty good. All right, so what I want you guys to do is flip your paper over, and I'd like you guys to do A through D for yours. You guys are going to deal with bats. No, it's that's a bear. What you did there. All right, so I think we got Joanna here. So Joanna, how do we find part A here for this problem? Mm-hmm. Okay. Like that? Oh, is it DT?
Oh, I don't know.
DT going home?
All right, so it's entered, right? So yeah, it's just this one, just that one. Oh, and then you said DT. Oh, I know what you mean. Okay, I'm sorry, I'm being silly. I was like, what's this DT function you're talking about? Okay, I'm with you. And you said 0 to 5, huh? I think it's 0 to 10. Because 6p.
Oh my God, I'm looking at the wrong one.
Oh.
I was on the G's one.
Oh, okay.
Yeah, 0 to 10.
There we go. Okay, so there's that. And what did you get for your answer there, Joanna?
I didn't solve it. I solved it in C.
Okay, that's fine. Let's see. Jonathan, did you get the number of bats here?
Yeah, are we supposed to announce the whole number?
Yeah, I mean we're talking about bats, so
Well, sometimes they don't.
yeah, they may not.
Or they lose a bunch. You never know.
That's a moral discussion. John was probing around that. Is a cat with one less leg any less a cat? I don't know. I don't know if I want to go there.
My God.
Because if that's the case, then
It's okay.
if you lose a piece of your hair, you've lost part of your humanity.
That's a good point.
Uh-huh. All right. How many bats have left the cave by 6:10 p.m.? So, Heather, how do we set this one up? Cool. And what'd you get for that? Okay. Now, before I don't really want to. I guess I'll call on somebody, but I want to show you guys something interesting here, and it just may have already been obvious to you, but in case it hasn't, I'll bring it up. So, Jill, what did you get for your answer on C, though?
Well, I guess you're 19.
Okay, good. Now check this out, guys. You know how I imagine a lot of you guys probably set it up the way that I did, right? You probably did the starting number of bats, which was how many? 120. And then you did plus integral from 0 to 10 of ET minus LT, right? Okay, well the thing is though is that we actually did all this math already because we start with 120 bats. How many bats did we gain in 10 minutes?
427.
And how many bats did we lose in 10 minutes?
228.
So actually you could have done it by hand. Oh. 228. So that would also give you 319. Yeah, you could just do it in pieces, right? Instead of all at once. Because you guys agree the integral property is you could take this integral and just do these separately, right? And we already calculated each of these separately, so it's just combining them. All right, but either way, this is still nice to see because it kind of shows you what this function in part D should look like. It should be 120 plus the integral from 0 to x or t. I guess it should be t since that's my input variable. Et minus lt. So that's a rate in, rate out question. And then to Monday we'll we will continue this worksheet, I think. So we're good. We're good.
Are you